Welcome back, students. So in the last session we dealt with inertia and Newton's first law of motion. Today we are going to enter the next topic of this chapter, that is Newton's second law of motion. So before we start with Newton's second law, we want to get acquainted with certain terms involved in it. So for that, let us consider an example. Suppose you and your friend are trying to break a glass, and your friend is having a giant rock in his hands to help him out to break the glass, and you only have a small marble piece in your hand. Okay, and your friend can easily break the glass wall with the help of that huge rock just by rolling it. Will you be able to break the glass wall by just rolling the small marble piece which is there in your hand? No. But your friend was able to break it by just rolling the huge rock. It is because heavier objects, huge rock is a heavier object, or to be more precise, it has more mass. So when an object has more mass, it will apply more force, and your friend were able to break the glass with the help of the giant rock. Now you only had a marble piece. When compared to the huge rock, marble piece has lesser mass. So it applied only lesser force on the glass wall. That is why the glass wall didn't break with the help of the marble piece. So from the example, it is clear that as mass of the object increases, force applied also increases. So heavier objects can apply greater force. Now, how can you break the wall with the help of the marble piece? How can you break the wall with the marble piece which is there in your hand? Yes, take a toy gun. Insert the marble ball into the toy gun and shoot it. Now you will be able to break the glass. Why? Because when we shoot, the velocity of the marble piece is too high, is too great, is too more. Velocity is more in that situation. So higher velocity objects can apply greater force, hence the glass wall broke. So from this example, it is clear that heavier object or objects with greater velocity can apply greater force. That is, force depends upon two quantities. One is mass and second one is velocity. So the quantities upon the force depends on are force depends on mass and velocity. That is, your friend had a huge rock with a greater mass. So that helped him to apply more force on the glass wall, and the glass wall broke. So greater mass can apply greater force, and you only had a small marble piece in your hand. So you sought the help of a toy gun in order to break the glass. So with the help of toy gun, you increased the velocity of the marble piece, and then you broke the glass wall. That is, objects with greater velocity can apply greater force. That is, force depends upon two factors, that is mass and velocity. and this gave work to a concept called momentum. This dependency of force on mass and velocity gave work to a concept called momentum. Momentum, that is, momentum is defined as the product of mass and velocity of an object. Suppose if you have an object of mass m, and if this object is moving with a velocity v, then momentum, which is represented using the small letter p, can be represented as the product of mass and velocity. Momentum is represented using the letter p, and p is equal to m into v, where m is the mass and v is the velocity. And the concept of momentum have many practical applications. Have you noticed a bowler take long run-ups when he bowl? A fast bowler take a long run-ups when he bowls. Why? Because this long run-ups helps him to gain velocity. So, long run-ups helps him to gain velocity, that is, velocity increases while he take long run-ups. As a result, in turn, momentum also increases. So, velocity, the long run-ups helps him to gain greater velocity, which in turn increases his momentum, and this momentum helps him to bowl faster. That is why he is taking long run-ups while he bowls. The same thing is applicable in the athletic meet called javelin throw. That is, in javelin throw, also in javelin throw, the athletes take a long run-up before the athletes throw the javelin. Again, there also, during the long run-up made by the athlete, he is trying to gain velocity, which in turn gives a gain in momentum, and this momentum help him to throw the javelin as far as possible. So, this momentum have many practical application. These are the two different examples where momentum is applied in case of sports. Okay. Now, let us see the unit of momentum. Now, we know that momentum is mass into velocity. Now, let us substitute the unit of mass. SI unit of mass is kilogram and SI unit of velocity is meter per second. That is, SI unit of momentum is kilogram meter per second. Kilogram meter per second, and here momentum is a vector quantity. Momentum is a vector quantity, that is, momentum depends upon its magnitude and on its direction. Momentum has both magnitude and direction, that is, momentum is a vector quantity. So, momentum is the product of mass and velocity. The representation of momentum is P, hence the formula is P is equal to M into V. SI unit of momentum is kilogram meter per second, and momentum is a vector quantity. Now, as we have discussed in the earlier class, an unbalanced force can change its velocity. An unbalanced force can change its velocity, which in turn changes its momentum. So, if we apply an unbalanced force onto an object, that force will change velocity. If velocity changes, momentum also gets changed according to the equation P is equal to m into v. According to this equation P is equal to m into v, if a force applied onto an object changes velocity, it will in turn changes its momentum. So, force changes velocity, which in turn changes its momentum. Okay? And this change in momentum also depends upon the time during which the force is being applied. It depends upon force. Change in momentum depends upon force, because only if force is applied, velocity will change and momentum will be changed. So, definitely the change in momentum depends upon force. It not only depends upon the force, it also depends upon the time during which force is being applied onto an object. For example, consider a car with a dead battery. Consider a car with a dead battery. And if you want to make the car started or accelerated, if you give a sudden push to the car, if you give a sudden push to a car which is having a dead battery, will it move? Will it get started? No. You have to give a push, you need to give a push gradually. Then only the car gets accelerated and gets started. So, you have to apply force gradually. If you give a sudden force on it, it won't get started. That means force should be applied gradually. So, that is the change in moment. In order to gain velocity, a force should be applied and it should be applied gradually. That is, velocity change means a change in momentum. Change in velocity means momentum also will be changed. So, in order to change velocity, a force should be applied, and force should be applied gradually. It should not be applied suddenly, it should be applied gradually. So, change in velocity means definitely the momentum will change. That is, change in momentum depends upon the force and the time during which force is applied. So, change in moment, in order to change velocity, we have to apply a force, and force should be applied gradually. Change in velocity means definitely the momentum will change. That is, change in momentum depends upon force and the time during which the force is applied. And this is what Newton stated in his second law. This is what Newton stated in his second law, that is, Newton's second law is rate of change of momentum is proportional to force. So, we have already told that change in momentum depends on force and time. This is what he incorporated into the second law, that is, rate of change of momentum is proportional to the unbalanced force. That is rate of change of momentum. So, rate of, the word rate of means divided by time. Rate of means with respect to time. Rate of means with respect to time. That is the meaning of rate of, divided by time. When you represent it mathematically, rate of means divided by time or with respect to time. This change of momentum with respect to time is directly proportional to unbalanced force. So, in order to change momentum, we need an unbalanced force, and force should be applied gradually. That means it also depends upon the time during which the force is being applied. So, the second law, suppose if initially if an object is moving with a momentum Pi, let the initial momentum be Pi. This is the initial momentum, the momentum with which the object was travelling initially. This is the initial momentum. Now, I can write Pi as, so formula to find momentum is mass into velocity. That is mass into this initial momentum. So, initial velocity, mass into initial velocity, that is Pi is, initial velocity can be represented using the letter u. So, initial momentum is m into u. So, initially an object m was moving with a velocity u. Initially an object with mass m was moving with a velocity u. Then the initial momentum of that object is m into u. Now, we applied an external unbalanced force onto it. When we apply an external unbalanced force onto that object, the velocity will change from u to v. When we apply an unbalanced force to that object, definitely the velocity will change, henceforth momentum also will change. So, initially the object of mass m was travelling with a velocity u, hence the initial momentum Pi is m into u. Now, we applied an unbalanced force onto that object. When we apply a force onto that object, definitely this velocity will change, which in turn changes its momentum. So, let final Pf be the final momentum. Pf be the final momentum. Now, Pf can be written as, again we know that the formula to find momentum is mass into velocity. So, Pf can be written as mass into, we are going for final momentum. So, mass into final velocity. Let the final velocity attained be v. By the application of force, let the final velocity attained be v. Then final momentum can be written as m into v. Pf, that is final momentum, is m into v. So, initially the object was moving with a velocity u, So, the initial momentum is represented using the equation m into u. On the application of force, the velocity u changed to v, the final velocity. Hence, the final momentum is m into v. Mark this as equation number 1 and this as equation number 2. The equations for initial momentum and final momentum. Now, according to the law, second law, rate of change of momentum. Now, change of momentum. Change of momentum is final momentum minus initial momentum. To find the change that occurred in momentum. Change means we need to go for subtraction. We need to go for difference. We need to take difference. So, change in momentum means final momentum minus initial momentum. Since we are finding change, we are going for difference. So, change in momentum is final momentum minus initial momentum, which is equal to final momentum is Pf minus initial momentum is Pi. Now, according to the statement, rate of change of momentum. Rate of change of momentum. So, change of momentum is Pf minus Pi. Change of momentum is Pf minus Pi. Change of momentum is Pf minus Pi. Rate of means divided by time. The word rate of means with respect to time or divided by time. So, rate of change of momentum means Pf minus Pi by t. This change of momentum on Pf minus Pi. Rate of means divided by time. That is, rate of change of momentum is Pf minus Pi by t. Now, again according to Newton's second law, we know that rate of change of momentum is proportional to unbalanced force. That is, rate of change of momentum is Pf minus Pi by t is proportional to unbalanced force. Is proportional to unbalanced force F. That is Pf minus Pi by t. In order to change this proportionality sign into equality sign, if we want to change proportionality sign to equality sign, we should multiply with a constant. We should multiply with a constant. To change proportionality sign to equality, we should multiply with a constant. So, equation becomes Pf minus Pi by t equal to constant into F. Let this constant be K. Pf minus Pi by t equal to K into F. Let this constant be K. That is, Pf minus Pi by t is equal to K into F. Let constant K equals 1. Let constant K equals 1. Then equation becomes Pf minus Pi by T is equal to 1 into F. Equal to 1 into F. Mark this as equation number 3. Pf minus Pi by T is equal to 1 into F. Mark that as equation number 3. Now, substitute equation 1 and equation 2 in equation 3. That is, equation 3 is Pf minus Pi by T is equal to F. This is equation number 3. Equation number 1 is Pi is m into u. This is equation number 1. Pf is equal to m into v is equation number 2. Now we are going to substitute equation 1 and 2 into 3 and we get Pf minus, substituting equation 1 and 2 into equation 3. What is Pf? Pf is, according to equation number 2, Pf is m into v. So instead of Pf, mv minus Pi. What is the value of Pi? M into u. According to equation number 1, Pi is m into u. So instead of Pi, mu. So Pf mv minus Pi is mu divided by T. So Pf minus Pi by T can be written as mv minus mu by T equal to F. So we have written equation number 3 in terms of equation number 1 and 2. Now in this equation m is common in the numerator. Let us take that common term m outside. So it becomes m into v minus u by T is equal to F. Is equal to F. Now what is v minus u by T? What is this v minus u by T? Already we have learnt in the first chapter that v minus u by T is the acceleration A. Change in velocity with respect to time. Rate of change of velocity is the acceleration. V minus u by T is the equation to find acceleration. So we can write this equation as m into, instead of v minus u by T, we can substitute acceleration equal to F. Since v minus u by T equal to A, we can write this equation as ma is equal to F. This is the mathematical form of Newton's second law. So Newton's second law is rate of change of momentum is proportional to the unbalanced force, or mathematically it can be stated as F is equal to ma. F is equal to ma, where F is the force, m the mass and a the acceleration. Now F is equal to ma is the mathematical statement of Newton's second law. Now let us find the unit of force. What is the unit of SI unit of mass? Kilogram. And SI unit of acceleration? Meter per second square. So the SI unit of force is either kilogram meter per second square or Newton So, these are the SI units of force, kilogram, meter per second square or Newton. Again, force is a vector quantity which has both magnitude and direction. Like momentum, force is also a vector quantity which has both magnitude and direction. Hope the session is clear. So, today we discussed about the momentum. So, before we started with momentum, we took an example and we figured out that force depends upon two factors, mass and velocity. And this gave work to a concept called momentum, represented by the letter P, and the formula is momentum P is equal to mass into velocity. And the change in momentum is caused by a change in velocity. And in order to change velocity, we need to apply an unbalanced force. And that unbalanced force will change its velocity, which will in turn changes its momentum. And that unbalanced force should be applied gradually. That is, change in momentum depends upon the force and on the time during which the force has been applied. This gave work to a concept called Newton's second law, stated that rate of change of momentum is proportional to unbalanced force, and the mathematical statement is F is equal to ma. So much topics were covered today in this session. Hope it is clear. That is, we have covered the Newton's second law, that is there in the page number 119. So, in this session we have covered the page number 119 of your NCERT textbook. Please see that after this session, read your textbook thoroughly and make the concept clear. Thank you.